In this video, I will continue talk about monotonic stack application. And today I want to talk about this problem. This problem is to find a non-empty continuous subarray and satisfy the following condition. The condition is in this subarray, the left most element of this subarray is no larger than the other element in the subarray. For this question, and now to directly give the idea. The idea is I need to use a monolithic monotonic increasing stack to ensure the next smaller element. For example, this is a subarray, and from 5, this is a increasing order, and for this for another element, and is less than the top element. That means, and I can find when I to compare the top element with the current input element, and I can ensure the next smaller element. For this, find the top element with this element. It generates a pair of next smaller elements. So for this one, and I can to for this one I can to generate the leftmost element separate and no larger than the other element. So let's assume this this index is J+1, and for this one I will ensure this one, and between the difference between this index and this index difference is the number of this subarray. And when I get the count, and I need to remove this top and continually to compare this one, and for this operation, and it's also found the smaller element, and to continue get the count between this index and this index, and until an element is smaller than this input element. So to emulate the monotonic stack, and to get the smaller element, we will get this return this result. And I will to use a count to record the current count of the subarray, matched subarray, and I need to define a stack. This stack will be record the index information. It's monolithic. And I will to input traverse this array. Traverse this array, and I encounter this is a monotonic increasing stack. Stack is empty, not empty, and every stack is peak element is a more than no larger than and this is the formula. No larger is smaller elements, and this current element. That means I need to pop the top element, but right now I need to first count this one. Count the current subarray subarray number, because the number is between this index and the current index distance. Stack is index, and the stack I will be stack PEK. That's the numbers. Stack save the index, and then stack will be push I pop and return count. But I have a corner case to consider. If the array is a structurally increasing sequence, and during this while loop, and I cannot encounter any input element less than the top element, and this will be set the count is 0. So for handle this exception, and I can add the water node in the end of this array. The water node value is the minimum value of integer, and it ensure every element can be get the next smaller have to get the next smaller element. So I need to add the resize the numbers, and will be add the number into the end. I need to define a new numbers, new int, and numbers plus 1, and 4. Equals 1, I versus I plus plus, and new numbers I will be the numbers corresponding every element value. New numbers last operation value is a integer minimum value. So that means I can to use this one to replace it. So that will be finish the monotonic increasing stack application for this problem, and I try to run it, and I will put all the test case, and will be this is a duplicate. The last one is a duplicate. For the duplicate, I will get okay. Duplicate is also can be handled. Right now, I run it, and it's beat up faster than 50%, and I will continue to reach. That is one, and I will to generate the C++ code. So for stack, and I will use stack is int, and right now in C++, and I can to numbers push back int mini, and then I will don't change it. It's empty. This will be size, and empty or translation the Java code to C++ code, and this is top. push back, try it, new stack, no new stack. This is the definition for C++ style. This will be finished. Run code, submit it. Yeah, it's passed faster than the about 90% of C++ online submission. And so for this problem, and the great thinking is a stack, monotonic stack to gain is easily to find the for this current operation to find the next great element, previous great element. It also can find the next smaller element and next previous smaller element. This will be use O(n) time complexity and to reduce from the naive solution O(n) square to O(n), and monotonic stack is a very broad application in data structure, and we need to take some time look through it and consider it. Hope that video helpful for you. Thank you very much.